Hi, welcome back to Circuits with Angel. Today we'll learn about breadboards. Not the ones that we use in the kitchen, but the ones that we will use in most of my videos to learn to assemble simple and fun circuits without having to permanently use components when we want to build a circuit. What prototyping solderless breadboards allow us to do is to design circuits and put our components on for testing without soldering them on forever. Once we demonstrate a circuit works, we can move on to soldering prototyping boards. Here's what that board looks like. We're not going to use them today, but I just want to show you how it looks. Now you may be wondering how a solderless prototyping breadboard actually works. On the inside of a breadboard, we have multiple conductive metal strips. Conductive means electricity can flow through the metal. Let me show you what all these lines, letters, and numbers mean using this small breadboard. On the sides here are what we call the power bars, clearly indicated by the plus and minus sign on the front. The plus is the positive rail. Generally they are colored red. And blue means negative, so they are colored blue. So when you see these colors, that's what they usually mean. Over here is 30 parallel lines of metal strips next to each other, numbered here on the side. That's just to label the lines, in case the circuit is more complex. The letters at the top and bottom here also do the same thing as the numbers. It helps with labeling. The middle gap of the breadboard actually has a name. It's called the DIP support because it allows us to add ICs perfectly. What's an IC? It's an integrated circuit. We won't use them right now because they are more complicated. But I thought I'd mention that there is a reason to having this middle line. This small breadboard that we have here can be expanded further by connecting multiple breadboards together, allowing us the options to build larger circuits. That's just a fun fact about these breadboards. So I'm going to show you what the conductive metal strips look like when they're taken out. I wouldn't try this at home, unless you're ready to break a breadboard. But if you'd like to give it a try, be ready for that. Let me take it out. Each one of the 5 sockets is actually a single connector. This connector holds the wire firmly when you insert it into the board. Using what we know now, I'm going to show you how to use this breadboard with an example. First, we take this 3-volt battery pack. We take the red wire that is the positive voltage, we insert the wire into the positive rail that has a red line next to it, and then we take the black wire. We plug it into the negative rail, which is the blue line on the breadboard. Next, we put in a jumper wire from the negative rail to an empty rail on the breadboard. So for this case, I'm using the negative rail to A21. And then we take a push button and connect the rail to where the jumper wire is connected to, across the DIP gap, like this. So making sure that one leg is plugged into the A21 line, and then connect this 470 ohm resistor to the opposite side, to an empty rail. I'm just going to pick a G10, and then after that we will connect the LED. I'll just use a green one. We will use the short leg to plug in first, because it is the negative leg, to G15. And then the longer leg, which is the positive leg, to the positive rail here. It doesn't matter where, just as long as it's in the positive rail. If I push the button here, it should turn on. Ta-da! By the way, don't make this circuit without a resistor. It'll probably blow up the LED. You should check out the resistor video for more info. Before the end of this video, I want to go over how our circuit works. First, negative voltage comes into the push button to the jumper wire, but the voltage does not travel to the 800 ohm resistor until we push the push button. And after the voltage goes through the resistor, it goes through the leg of the LED. Now the LED has negative voltage. The positive leg comes in at the other leg of the LED, completing the circuit. Now this was all made by the conductive metal strips that I showed you before. Thanks for watching my video. See you next time.